The cooperation between Leonardo of Italy and Baker Technologies of Turkey on the production of the Kizilelma uncrewed fighter aircraft in Italy is one of the most consequential developments in contemporary defense industrial strategy. It symbolizes the merging of two parallel traditions in military aviation: the long-established European aerospace engineering culture, rooted in detailed certification processes and complex multinational programs, and the newer, highly agile Turkish model that emphasizes rapid prototyping, modularity, and affordability. Together they reflect a growing recognition that the future of combat aviation will be shaped not by isolated national efforts but by interlinked ecosystems capable of combining speed, scale, and technology integration. To understand the depth of this partnership, it helps to examine how each partner arrived at this point. Leonardo, Italy's largest defense company, has inherited a lineage that runs from the early days of Fiat Aviazione and Aeritalia through the modern conglomerate Finmeccanica. Over decades, it developed core competencies in avionics, radar, helicopters, and electronic warfare. Its factories are distributed across Italy, including advanced composite manufacturing centers such as the Grottaglie facility in the Apulia region. That plant was built primarily to produce composite fuselage sections for the Boeing 787 Dreamliner, making it one of Europe's most sophisticated automated production sites for large aerostructures. However, the cyclical nature of civil aviation and the limits of subcontracting arrangements have pushed Leonardo to seek new uses for its capacity. The arrival of Kizilelma provides such an opportunity. Baker Technologies emerged from a very different environment. Starting as a small private firm focused on flight control software, it grew rapidly through its Bayraktar TB2, TB3, and Akin-C drones, which demonstrated effectiveness in real conflicts. Baker's approach to development has been characterized by short iteration cycles, digital design, and the use of commercially available technologies to keep costs low. Its success in scaling up production and continuously improving its designs has made it an unusual case of a defense manufacturer that behaves more like a technology startup than a traditional state-backed conglomerate. Kizilelma is the natural progression of this trajectory, taking the company into the realm of jet-powered combat aircraft. The partnership's industrial structure under the joint venture LBA Systems is therefore built on complementarity. Baker provides the airframe design, autonomous flight software, and system architecture. Leonardo contributes composite manufacturing, avionics, electronic warfare systems, and the organizational infrastructure to integrate production within European regulatory frameworks. Grottaglie, in particular, offers a ready-made environment for high-precision composite work. The plan is to produce Kizilelma airframes there, install Italian-made electronics and communications systems, and deliver a version that meets NATO interoperability standards. This combination not only ensures a steady workload for Leonardo's facility but also brings Turkish innovation into a European industrial context. The wider layout of LBA Systems extends beyond a single site. The Ronchi dei Legionari plant in northern Italy is designated for the TB3 drone and Leonardo's Merak target aircraft, while the Villanova de Albenga facility, now under Baker ownership through its acquisition of Piaggio Aerospace, will handle the TB2 and Akin-C. Each location contributes different specializations: composites and large structure assembly in Grottaglie, smaller UAV production and flight testing in Ronchi, and airframe integration in Villanova. The engineering centers in Rome and Turin serve as hubs for avionics development, cybersecurity, and mission system integration. This distributed model mirrors the structure of major European fighter programs but operates with greater agility, allowing each site to adapt to demand and technology updates more quickly than traditional state-led projects. From a policy standpoint, this collaboration strengthens the industrial bases of both nations. For Turkey, manufacturing in Italy establishes a bridge into the European Union's defense production sphere. It enables the company to access European suppliers, secure certification more easily, and open doors for exports to NATO countries that might otherwise be restricted. It also demonstrates that Turkish aerospace products can meet the rigorous quality standards of Western production environments. For Italy, the partnership delivers immediate exposure to advanced uncrewed combat aircraft technology, positioning it as a practical leader within Europe's shift toward automation and autonomy in air warfare. It also provides a hedge against the long timelines and budgetary uncertainties of the larger sixth-generation fighter programs. Kizilelma itself sits at the heart of this industrial vision. The aircraft is designed to be highly flexible. It can perform air-to-air engagements, strike missions, reconnaissance, and electronic warfare. It is powered by a turbofan engine capable of producing speeds approaching the transonic range, giving it the ability to operate alongside manned fighters. Its composite airframe uses radar-absorbing materials and internal weapon bays to reduce detectability. The aircraft's control software allows both remote piloting and autonomous operations, including takeoff, landing, and tactical decision-making within predefined parameters. This autonomy is essential for future manned-unmanned teaming, where split-second coordination between aircraft cannot depend solely on human input. For Turkey, Kizilelma is not an isolated platform but part of a broader system of systems centered around the Khan fighter jet. Khan represents Turkey's ambition to field an indigenous 5th to 6th generation fighter capable of competing with the world's most advanced aircraft. Developed by Turkish aerospace industries, it includes stealth shaping, advanced avionics, and internal sensors designed to integrate seamlessly with unmanned systems like Kizilelma. In Turkish doctrine, Khan would act as the command and decision-making hub, directing a formation of uncrewed aircraft that perform different roles, some as decoys, others as sensor carriers or strike assets. This concept is consistent with global trends in combat aviation, where nations are developing autonomous wingmen to accompany their primary fighters. Italy's role in the Global Combat Air Program (GCAP), alongside the United Kingdom and Japan, aligns with this vision. GCAP also plans to include autonomous adjuncts and loyal wingmen as part of its future system of systems. However, with operational prototypes expected only in the 2030s, Italy's involvement in Kizilelma gives it an earlier opportunity to gain operational experience with such systems. Data from Italian-built Kizilelmas could feed into GCAP's research on communications, sensor fusion, and mission management. In this way, the Kizilelma project acts as a practical testbed for technologies and tactics that will later underpin Europe's sixth-generation air combat doctrine. The implications extend beyond technology to economic and geopolitical considerations. The partnership strengthens the southern flank of Europe's defense industrial base, which has often lagged behind northern and western Europe in aerospace investment. It brings skilled jobs and technological capabilities to regions like Apulia and Liguria while deepening Italy's ties with a NATO ally whose defense industry is increasingly influential. For Turkey, it diversifies export channels and embeds its aerospace sector in European value chains, a move that could mitigate risks from supply restrictions or shifting political relations. At a strategic level, this partnership demonstrates that future airpower will be defined by networks rather than single platforms. A modern air force will depend on the integration of sensors, communications, and command systems across both manned and unmanned assets. Kizilelma's role in this environment is to provide an adaptable, relatively low-cost platform that can be upgraded continuously through software and modular payloads. This allows both Italy and Turkey to experiment with autonomous decision-making, swarm coordination, and electronic warfare countermeasures in real-world conditions, long before these capabilities become standard in larger fighter programs. There is also a cultural transformation embedded in this cooperation. Leonardo, a company steeped in decades of formal project management and rigid development cycles, is adopting aspects of Baker's iterative, software-driven design philosophy. Conversely, Baker gains insight into the rigorous certification, documentation, and integration practices that define European aerospace manufacturing. The result could be a hybrid model combining the best of both, the speed and flexibility of a technology startup with the precision and reliability of a mature aerospace manufacturer. The success of this initiative will depend on how effectively both companies navigate regulatory, technical, and political complexities. Production of military aircraft within the EU requires strict export control compliance and coordination with defense ministries. Integration of Turkish and Italian technologies must also respect intellectual property and security considerations. Yet, both governments appear to view this as a mutually beneficial endeavor, supporting it through industrial cooperation frameworks and regular defense dialogue. If approvals proceed on schedule, initial assembly of Italian-built Kizilelma aircraft could begin within the next year, with deliveries following soon after. Beyond the immediate industrial benefits, the program represents a tangible step toward the evolving concept of air combat networks, where machines collaborate, share data, and adapt to threats faster than humans alone could manage. The Kizilelma's autonomy algorithms, communication links, and mission planning software are being developed with this vision in mind. Testing these systems in European airspace, under NATO standards, will accelerate understanding of how such networks function in complex electromagnetic environments. This, in turn, will inform not only Turkish and Italian operations but also broader alliance planning for joint missions. In the long term, the presence of Kizilelma production in Italy could serve as a foundation for a broader European family of uncrewed combat aircraft. Once the platform is established, Leonardo and Baker could adapt it for different roles, such as electronic attack, suppression of enemy air defenses, or long-range strike. It could also become a basis for cooperative programs involving other NATO members interested in cost-effective autonomous aircraft. By demonstrating that such collaboration can work at an industrial level, the project may encourage further integration among mid-sized defense industries across Europe and its allies. The Leonardo-Baker partnership shows how the global defense landscape is changing. The future of airpower lies not only in stealthy manned fighters but in the combination of human skill and machine autonomy. The Kizilelma, produced in Italy and Turkey, embodies that transition. It stands as both a technological experiment and an economic strategy, linking two nations through shared production, knowledge, and ambition. Whether viewed from the perspective of industrial modernization, strategic alignment, or technological innovation, this cooperation illustrates the emerging reality that no single country can develop the next generation of air combat systems alone. Collaboration, flexibility, and the blending of diverse technological cultures will define the aircraft and the defense partnerships of the decades to come.